Hi, everybody. Our next video lesson here is on, I'm going to call it HL, but on your calendar it's proving right triangles are congruent. You'll understand in a bit here why I'm calling it HL. Your note should look like this. So if you want to take out that page and be on par with me, oops, we don't want that. We want this one. Okay, here we go. Forewarning you, the printer at school must be kind of running out of ink, so I'm sorry that my copies are bad. I could print it again at home. I don't want to waste paper, so I think we're okay to just gonna bear through it together, right? Okay, so today is our last shortcut where you're gonna learn for proving triangles congruent. It's called HL because it only works with right triangles. So let's see what this will look like. Ooh, that is so bad. I'm sorry, you guys. But good thing you have a copy in front of you. So, okay, so hypotenuse leg, or HL. It says if the hypotenuse and a leg of one right triangle is congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So the reason that this only works for right triangles is because right triangles are the only triangles that have a hypotenuse. So now if you're still a little lost, what makes a triangle a right triangle? The right angle, okay? So if it has a right angle, it's considered a right triangle, and only right triangles have hypotenuses. And if you're kind of forgetting, the hypotenuse is the leg across from the right angle, okay? So if you're still confused about that, either Google stuff about right triangles or ask me in class and I can break it down further for you. Okay, so it says if the hypotenuses, so again, that's the sides across from the right angles. There's my hypotenuse. So if they are congruent, they have the one tick mark and the one tick mark. So if BC is congruent to EF, and if we have a leg, so the other two sides of your triangles would be called legs of that right triangle. So if I have another pair of legs on that right triangle, so like AB and DE, then that is enough information to say that these two triangles are congruent. So then triangle ABC is congruent to triangle DEF. So just to kind of reiterate, it has to be a right triangle. So once that's established that it is a right triangle, then you can check hypotenuse. Are the hypotenuses the same? Which we did here, that's our H. And then if another pair of legs are the same, L. So how would this look different from the triangles we had seen before? So let's say before you knew HL, you would go around this triangle. I'm gonna draw it right here just because it's a little bit better. Okay, so these are the markings on that triangle. So you'd go around, oh, that's a side marking, and an angle. So we know that I can't have an SSA or an ASS, right? We had said that doesn't work for us. If you ever get a situation that looks like this, check to see if your angle is that right angle, because if it is that right angle, then HL works because you established that's a right triangle. This would be your hypotenuse, leg. Do you guys see the difference? I know it's a little confusing, but the HL, remember, only works if it's a right triangle. Okay, let's try identify some of these. So now this is just a Mod Podge of all of our shortcuts here. Ooh, this is rough. Okay. So we have to figure out if the triangles are congruent, and if so, by which postulate or theorem, aka what shortcut, okay? So if we look here, if I look, I have one tick mark and one tick mark, that's a side. I have a right angle and a right angle, so that's an angle marking. And then two tick marks is another side. If I check over here, I have the exact same side, angle, side. So we would know this is side, angle, side. Our next one here, let's look. We have a tick mark and a tick mark, so that's a side. We have an archy mark and an archy mark, so that's an angle. And then we have a right angle and a right angle for another angle. So if I look, angle, angle, side, and just to make sure it works over here, angle, angle, side. So we are good to go. Okay, this next one here, we have a right angle and a right angle. So angle, angle, tick mark, side, side, another archy mark, angle. So this would be angle, side, angle. Okay, this one's really faint. Sorry about that, folks. So I have a tick mark here and a tick mark there. So that's a side and another side. And then I have 2 tick marks and 2 tick marks for another side and another side. And then I have an angle and an angle. So looking right now, I would have SSA or ASS, which again, we know we're not supposed to have. But now I want you to look. Do I have right triangles? Because if you do, oh, I have a right angle and a right angle. So that's a right triangle in both situations. Now my hypotenuses are the same. So now that turns to an H and an H. And I do have a pair of legs that are the same. So now, to a problem that we would have said not congruent, we are actually able to say HL. And again, this won't happen every time you have the SSA situation, only if it's a right angle. So I'm going to repeat that one more time. This only works with right triangles. So if there's a right angle, you can use HL. And then our last one here, we have an archy mark with an archy mark, 2 archy marks with 2 archy marks, and 2 right angles. So if I went around, those are all angle markings. Is angle a thing? Nope, that's not enough information. Okay. Now we have 2 proofs for us to complete here. So we're assuming they probably have to deal with HL since that's what our lessons is on, which is good because that's they're set up a little bit different than the other ones. So let's just start off by making our table here. So we're gonna have statements with our reasons column. Okay, so here we go. Let's see it. So AD is congruent to BC, which they kindly marked for us. Now I can write it down here. AD is congruent to BC. Why did I write that? Because it was given. Then they tell us angle A and angle C are right angles. So angle A and angle C are right angles. That was also given. So again, remember I said they're always giving you a given for a reason. Like it's not just like for funsies, right? Like there's a purpose for them telling us that those angles are right angles. So now what kind of triangles do we have if these are right angles? They're right triangles, right? And you need to have a right triangle to prove HL. So now our next step is going to say triangle ADB and triangle CBA or CBD, excuse me, are right triangles. Why am I able to say that? Well, by definition of a right triangle, they're right triangles because the definition of a right triangle is that it has a right angle, and that's what we just said. So definition of right triangles. Oops. Okay. So now we're looking at this picture, like what are some other things that we know, right? Because we ran out of our givens. Now, what are some other things we know? Well, we can see that BD is in both triangles, right? So I can say that BD is congruent to BD by the reflexive property. So now if I look, BD in both triangles is our H. And then I have a pair of legs that I already said are congruent because that was given to us. So actually, folks, we're done. we have now shown that this triangle here and this bottom one are congruent by HL. So again, we had our right triangles. We had to say that. So that has to be true. We had our legs congruent. That was right there. And then our hypotenuses are congruent. So that is enough information to say that those two triangles are congruent by HL. Okay, we have one more, and we're just going to modify it just a tish. We haven't yet done a proof where we're proving that parts of our triangles of our congruent triangles are congruent. So where this says parallel right here, will you guys cross that off and make it a congruent symbol? So our end goal is to show that BC is congruent to AD. Okay, so let's start off again with our statements. And our reasons. So if we look here, let's see what they're giving us. They're telling us that angle A and angle C are right angles. So we can write that down, I suppose. Angle A and angle C are right angles. Why? That was free information. It was given to us. And then they also tell us, remember those straight up and down lines mean that they're parallel. So now AB is parallel to CD. AB is parallel to DC, given. Okay, so we kind of have a lot to talk about here. So our end goal is to show that BC is congruent to AD. Before I can even say anything about those two things, I have to show those triangles are congruent. So that's our first job. We have to show that those triangles are congruent, which we've done many times now, so we should be able to handle that. So now let's go back to our givens here and think, what are our givens telling us? So again, if A and C are right angles, that's always basically telling you that you have right triangles. So whenever you're given right angles, it wants you to make that leap of knowing that they're right triangles. So now we can say triangle ABD and triangle CDB are right triangles. Why? They have right angles, so that's by definition of a right triangle. Okay, so we used up that given. Now, what would be significant in them telling us AB is parallel to DC? Whenever they give you parallel lines, think of last chapter. What did parallel lines give us? They gave us congruent angles. So again, just like when you're given a right angle, they want you to make the leap of right triangles. Whenever you're given parallel lines, they want you to make the leap of equal angles. So if I look here, here are my parallel lines. I would have alternate interior angles that are congruent. So we have angle A, got to trace it out, ABD is congruent to angle CDB. And that would be alternate interior angles. So now we've used up our given, kids. What else do we know? Well, by just looking at our picture, how many times have we seen this? Where BD is equal to itself. So BD is congruent to BD. What property is that? That's the reflexive property. So now let's see if we have enough information to show that these triangles are congruent. So we have two congruent angles and a side, right? So that could be angle, angle, side. So I guess, to be honest, folks, I thought this was going in a different direction when we started this proof. So we really didn't have to say this line here. I guess the fact that they're right triangles doesn't really make a difference because we're not going to end up using HL. So we actually, though, if we're going to use angle, angle, side, we have to say that angle A is congruent to angle C because they're both right angles. So we can say all right angles are congruent. Running out of space. Okay. So now I have enough information to say triangle ABD is congruent to triangle CDB by angle, angle, side. And then I talked about this at the very beginning of the chapter. We had this thing that I said CPCTC. Corresponding parts of congruent triangles are congruent. We've used that a lot, like when we use our mapping. So when you have like your little code, right, your corresponding parts are the pieces that match. So all that's saying is pieces that are in the same place are congruent if those triangles are equal. So now that I've shown that these two triangles are congruent, we have enough to say that BC is congruent to AD because they're in matching spots. So we can finish by saying BC is congruent to AD because they're corresponding parts. So again, corresponding parts of congruent triangles are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. This proof took a turn that I kind of forgot happened, so I apologize. We will practice more proofs kind of like at this level when I see you next, since we've kind of done some pretty basic ones up until now. Then the rest of the week, we are just doing some more proof practice just so we can become more comfortable with them. Thank you for watching. It makes my life a lot easier in class when you guys do your job by watching notes at home. I hope you have a super rest of your day, and we will see you soon.